Hi everyone, we're Group I and we're here today to present our DSS Group Assessment. My name is Nilesh and these are my colleagues. We're going to use the Compass Group as our case study. We're going to discuss the company background as well as the industry sector, followed by problems, DSS tools and techniques to solve these, along with recommendations. I will now discuss the background. The Compass Group was founded in 1941. It's a multinational organisation, operates in over 50 countries. I actually worked there previously for 2 years, so I have first-hand experience of problems going on there at the moment. On screen is an image which has a few interesting statistics. It just gives you an idea of the scale of the company. Over 60,000 employees and 1.8 billion annual turnover. However, because of the size of the company, when we talk about the problems, we focus on one specific example of the company, which is Rico Arena, who they provide to. I'm now going to pass you on to Etisan.
The industry sectors for the Compass, it is different or the various within business and industry, education and healthcare, and also the sports senior living. But the main, or according to the annual report which is published in 2014, the main sectors is business and industry, healthcare, and they are, or regarding to the revenue, they have 60% of the total revenue from these sectors. Now we move to the competitors. The first company, the competitor, which is Aramarx, the revenue of the company, which is 12 billion pounds, and it's lower than the Compass company, which is mentioned by my colleague, which is 17 pounds. And they are having providing facilities, clothing, and clothing, and they have different sectors, which is business, education, and healthcare. And also in that, also in another second competitor, which is Sodexo, and they have also lower revenue comparing with the Compass. Now my colleague will continue.
Thank you. And Compass Group is the largest food service company of the world, and they has operation in over 15 countries, and they employ more than 500,000 people and serve more than 4 billion meals each year. Also, Compass Group is the #1 on FM Top List 2015. Followed by Aramark and Sodexo. And Compass Group is the largest scale in all operations, which including the food, catering, canteen, and cleaning and property management. And Compass company caters to over 15 different countries. Aramark caters to 21 different countries, and Sodexo caters only Paris market. And my colleague Igwani will talk about the product.
We had most of these products and services already, but I'll go through them. They deal majorly in food. Compass Group is known for their food services. They have that across different segments. They deal in retail shops and supermarkets. They have facilities management also, and support, definitely things like cleaning. It's actually their cleaning and other property support, and then they deal in security. They have a small security arm, but their major investments go to the food services, and we'll see why in the next slide. Their unique selling point against what the competitors have is the fact that they have bespoke services. Now, what Compass does is that they have different food segments for different food outlets for different segments. So they cater to education, they cater to the public sector, they cater to government, and they cater to military. So imagine that they have levy, for instance, that caters to sports, and they have charter laws that cater to education. So these are specialized, they have specialized solutions for specialized needs. They cater to old people as well. So they have these services which makes them really, really stand out, because as against what the competitors have, which is just general, you eat whatever in the same place, these people have different food aspects. The same thing with their facilities management. They cater differently to hotels. The part that caters differently to hotels is another part. The part that caters to schools, that clean the school, is another organization. So that's what they have. Apart from the specialization which is guaranteed, they have a broad customer base. They serve 50 countries. Aramark, which is their second, and which has been tying with them, following them for 5 years now, just has a broad customer base of 21 countries as against 50 countries. I think that that's a unique selling point for them, the fact that they have a lot of customers. So my colleague will talk about the problems that we've identified in Compass Group, but they have even identified and they will try to find ways to remedy them.
Okay, so the three problems we're going to focus on today are the food wastage within the RICO arena, the resource and staff management within the RICO arena, and delivery and supply issues. So the first problem is the level of food waste. Now, obviously I've worked there, as I said, so I've had first-hand experience with this, and I'm going to give you an example of the level of food waste at the RICO. So at the end of every match, so you've got imagine 38 matches a season, etc. At the end of every match, per kiosk, there was up to 40 pies at least wasted. That's just pies, not mentioning any of the foods. So there's up to 20 kiosks operating at a time. So we're talking about 800 pies there. That's just one small sector. So obviously it's a massive, massive issue, because if they're wasting that level of food, it's going to obviously be affecting their sales, their profit, and their performance. I'm now going to pass you on to Ethan, who's going to discuss how they're currently trying to solve this issue.
Currently, train trucks is one of the important parts for the Compass Group to reduce the food, to deal with the food waste issue. Each staff in the Compass Group have their own waste bins and logs, and each staff need to record what kind of the food they dropped into the bins each day. Then those data will be uploaded to the internet and can be tracked. Then a weekly report will be produced. It is more easier to reduce the food waste by identifying where those food waste from. And then reward can be given to the staff that can efficiently reduce the food waste. It is easy and it works. And my colleague will mention about it.
Okay, well, the behavioral change he's trying to talk about, what he's trying to talk about is the behavioral change of the people, the staff. And if we limit the solutions to just behavioral changes, we know that that cannot be effective. That's why presently what they have is close to a 5% reduction in waste, which is not, which really is not an optimal solution. So we propose for tools a spreadsheet using Microsoft Excel. The techniques that we are proposing for this particular problem is optimization using mathematical representation. We actually found out that there's a lot of mathematics that can go into things like this, calculating food waste, getting regression analysis and all that. We also had predictions using statistical techniques, so we actually created a spreadsheet which does this well for us. And in our spreadsheet, next slide please. In our spreadsheet, what we did was, of course, to get we sampled 4 different snacks. There are major snacks, butter, fries, cake, bread, and then we had, of course, the ingredients, and we were able to break it down to the amount of what ingredients you have per food type. Because this is it in summation, quantity of ingredients used per unit of all food types. Now this is actually the variable, and this is where they're going to be imputing data. The quantities of food items sold weekly. So on Monday, for instance, they have all this, they have 5 burgers sold, 6, this and that. And with this, we're able to get the total number of food items sold per week, total number of burgers and all that. Now how that translates here is that at this, next slide please, you have the total number of ingredients used weekly in grams. So here you're able to compute, with simple mathematical summations and all that, how much of flour, how much of sugar actually leaves the company. So we were able to get this, and this was interesting because we were able to now see, oh, these are the ingredients that go. Okay, and after that, we are able to calculate the price per weight. This is, say they spend 1.2 pounds, and the total number of ingredients wasted weekly is this. So this is actually the loss. When you think you're wasting just 5 burgers and 6 snacks and all that, this is what you are losing, loss in GP per week. So this makes them really conscious that, oh, something is actually happening here that needs to be rectified. Now with this, we're able to implement, we came down, sorry, previous slide or something I wanted to show. Here we've been able to calculate the average daily waste, which we use per week in the next slide. Sorry. So we actually did this and got daily, burger, fries, cake, bread, so 16 average daily waste, considering that if they lose 50 a week, on average, how much do they lose every day? We put this into a graph and it was very interesting what we found. We said, okay, fine, this is how much waste. We remember that we're calculating consumption in the first part. Now, we are able to use this to calculate waste, because how much you consume and how much you waste can actually be calculated there. And then we use forecasting here to get how much, this is going to help us. This thing was forecasted is going to help us know how much actually we as Compass Group should make every day. I don't know if, so that we can prevent waste. So next slide, I'm afraid. And then with this average consumption here, that's what is here, predicted weekly sales. With this, we're able to cut waste a lot because we can now tell we don't have to make more than 5 burgers, but this is what we get every day. And then we have an input analyzer that was able to tell us the mean, deviations from the mean, so that we know we can measure, we can have a graph of anticipated and actual. So this is going to help us predict daily waste. But the end of time, I'll stop there, but this is something we actually created and saw work. So we thought that this would actually be an optimal solution for them, provided they have start feeding data into the system. Of course, if you don't feed in data, how are you able to get this to work? Or if you feed in data into the system and you have 50 weeks, for instance, if you have a year project, then you're able to say, oh, this is how much, and then it's able to cover it by, I don't think it's going to be a lot more than 5%. We don't have that statistic, but we're very sure it's will be better than the behavioral change. This solution can also help them check which foods they have low purchase. Because when we were creating this spreadsheet, we realized that there were some that actually were going plummeting. So we're like, over the weeks, this is actually going down. So that's what with the recommendations we would give as a company. The next problem is
okay, so the second problem we're going to talk about is the resource and staff management. Now, this is more of a case of queues building up and resources not being utilised efficiently. So we're talking about kiosks being closed because certain areas are quiet in the stadium. However, this is causing issues more than solving problems. For example, the main kiosk will be open, there'll be big queues, staff will then panic thinking everybody wants food, cook loads of food. This interrelates to the first problem, will lead to more waste when really everyone wants a beer. So, Edwin Sam's going to talk to you about how they're currently trying to solve this issue.
This issue, they do not have any solution. They use the papers and they use their observation, but the company aims to reduce the staff queues by by managing the staff. So my colleague will talk about it.
What they've been doing is get 3 staff or more on one column, on one counter, and that has not been effective. We tried to use the arena simulation tool because of course it describes what is currently existing, and it also can optimize the solution. So in the arena tool, what we had here was the present day scenario, which is that you order food from counter, you wait for the food, you eat the food and all that, and this is what they presently do. Right now on our simulation before, we had 3 guys on one counter. On the same simulation, we tried to run it, and from 8 o'clock, which in the previous simulation, to 10:53 p.m., they are attending to just 100 staff. That's not good for a company like Compass. Now they have a lot of queues. We just showed this to show that there's obviously something wrong. And then we said, okay, instead of adding more people to one counter, can we add another counter? Say they sell drinks, and then we're able to introduce another counter with just 1 staff. We left 3 staff here, and we entered food or drink. And then by the time we did this, at 1:59 p.m., we were able to see that they were done selling to the 100 people, and we said, wow, this is interesting. So if you add more counters and more counters, you can actually scale your results. So that's it can be scaled for optimal results, and it can be applied to other areas of business besides the food. Their retail and where they have food can also have this. So the third problem.
Okay, so the third problem is delivery and supply issues. Been experiencing late deliveries and often having problems with supplies. They don't know what their minimum stock level is and their maximum. The warehouse is always overloaded or they don't have enough stock. So for this, Epson, I'm going to give you a quick explanation of how they're currently trying to solve this.
The company wants to ensure that the package or the delivery deliver in the exact time or expected time, and they are using we are suggesting that the Walmart would be using Walmart technique like data mining as
Okay, so what we've recommended is, in class we talked about the Walmart case study a few weeks ago, where they use data mining and data warehousing to solve these similar issues. For example, they use data warehousing to
using distance as a variable to show what is the shortest distance to deliver the packet. So by constructing these assumptions using nearest neighborhood, they will have a result, and the decision maker will decide using this data which is the optimal solution for this logistic problem. So my colleague will conclude.
Okay, in conclusion, we'll just problem 3 actually. So to maximize this, you train the dispatchers, because dispatchers need to understand, have skill and experience to be able to use the GUI that show to them. In some trucks, you have things like OBC, that's the onboard computer, to be able to work this through so that they know exactly what distances they are taking and all that. Data mining will help them predict sales and quantity required each day, besides what just planning for events. So we'll quickly rush to the conclusion. In conclusion, we'd just like to say that business decision makers have to, of course, go through the stages of intelligence, design, choice, and implementation. And in all of this, you have to, from the beginning, know that have a clear problems, even if they are, whether they are structured, semi-structured or non-structured. And you also have to decide to what's your goal. You have to reduce profit, you have to reduce cost and increase profit. With this, you'll be well on your way to having a better better market position. Yeah, thank you.
Okay, thank you.